Mr. Cook here again. Today we're going to do our first lab on what are called parallel circuits. You should already have mastered series circuits where the components follow each other in line. This should look familiar as a standard series circuit. Comes out of the battery, goes through the switch, goes through our light bulbs, comes back to the battery in a series, one step after another. Today, however, we are dealing with parallel circuits. If you remember from math, parallel are two lines that don't touch. They are always evenly spot. So if I went on forever, they would never touch. They can be this way, they can be this way. But the idea is they're side by side and they go on. That's where the name parallel comes from. So as we start building it today, you are going to need to gather your materials, your lab sheet, as always. Everybody must do a lab sheet, even if you help each other out. You will need a digital multimeter. We're going to be measuring voltage at various spots and across the bulbs again. You will need your battery pack. I mentioned before it has a little bolt here that is perfect for the negative side or the ground. Positive side, not so much. Little hint, I always stick in a paper clip. Makes it easier, particularly since we're using leads, cables with alligator clips. You will need the 3 bulbs. Again, 3 of these. The switch, just because it looks cool to put a switch in all our circuits. And you'll need a collection of the alligator clips again. It doesn't really matter what color, just so we hook them up. To make it easier to follow, I took a couple and I taped them together. You don't need to do this. I just kind of made it shorter. Hopefully it'll be easier for you to follow what is going on. So the first thing you are going to do is look at the schematic diagram of a parallel circuit. Notice I have my battery and my switch. It goes through one bulb, and you notice these 2 bulbs are parallel. This line and this line don't touch, and they're connected together. This is why we call it a parallel circuit. Here's what's kind of cool. Remember before I said for a complete circuit in a series, it has to run through all the components. Not so much on here. If I come out of here, I can go up and my current will run through this bulb and come back to the battery. Notice it hasn't touched the other bulb. It can also run out, go through the other bulb at the same time, and go back to the battery. So there's a couple paths the current can follow this time as opposed to in a series circuit. When they're parallel, the current can have its choice. So we're going to see how that goes. So this picture is on your lab sheet and you are going to build it. Let me crank this down so we can kind of see what's going on here. Oh, I got to keep my handsome face in here. So I'm going to take my battery pack. I will connect my leads, my negative to there, my positive to my paper clip. I'm going to come out and I'm going to go to one battery, one side of a bulb. Here's where it gets a little tricky. I'm going and I'm doing this top wire here first. So I'm going to go to there. Notice this little node goes to that bulb. It also goes to another bulb. So I would take, I'm using my red cables here. Where I hooked up from the battery pack, I will continue going and I will move it down to another battery. So I don't have anything continuing there yet. Now on the negative side, it comes out and it goes to my first bulb. My negative side is going to come out. Oops, I forgot to put in my switch. Excuse me, Mr. Cook made an error. That happens once in a while. So throw my switch in place. Once again, this is the thrill of live video. So it goes through my switch to my first bulb, from my first bulb to my next bulb. So now I have switch, bulb, bulb, all on one side of bulbs. Now I'm going to go on the other side of the bulbs and hook up my other lead. So that's one black lead to there, and I'm trying to use different colored cables so you can kind of see what's going on. and here. So if you can follow along on here, I have my battery pack. Goes to my switch. Red goes to one side of the bulb, black to the other side of the bulb. My red continues on to the next bulb, and then on the other side the black continues on. So now when I go, I got two lights going. I got my current flowing in through this one. I got my current flowing in through that one. A little hard to see on this one. So now I have the parallels going. Now you're going to do your measurements. Get your little switch, go to DC voltage, and I'm going to have you do several measurements. You are going to ask and follow on the lab sheet so you can do this correctly. You're going to measure across the battery pack. You're going to measure across this light bulb, voltage on each side of the light bulb, and you're going to measure across on this side of the light bulb and see if we have the same voltage drop for each light bulb. It should be slightly different than on the series one. Then you're going to go back to your sheet, fill it out. Has a little essay question where you have to fill out what's going. Now, here's the thrill. You have two of them in parallel. I want you to add a third, and I want you to figure out how you're going to draw the schematic and how you would add a third so they all stay in parallel, and then do your measurements across each of the three bulbs as three. Then they have his little experiment where, just like before, I don't want you to see all the bulbs here, but I want you to go and I want you to take one of the bulbs, and which one can we see? And I want you to unscrew the bulb and notice what happens to the other bulbs. Does it act the same as it did in the series circuit or not? I'll leave that as a surprise for you. So, for today's lab, you are going to build this parallel circuit. You are going to take measurements across the battery, across each of the bulbs. Then you are going to add in a third bulb, so you have a third bulb in parallel, and take the voltages across all three of the bulbs. Then you're going to unscrew different bulbs at a time and see what happens to the bulbs that are still screwed in. Have fun playing with parallel circuits. This is Mr. Cook. I'll catch you at the next lab.